The stimulus for this seminar is largely from within the industry itself, where we see in the Australian forest industry a very significant movement through that structural change of the plantation competition. So we've got now in Australia somewhere between 85 to 90% of our wood panels and sawn timber produced from plantations. We've got our chip export sector, which is of course a major part of our native forest industry. Traditionally, well, since the 1980s, has been chip exports. Now that is being rapidly overtaken by the plantation competition, and that competition will intensify over the next 3 or so years. So all of this is leading to the question of what do we do with native forests? And we have on one side the forest ecologists who say, well, these are big stores of carbon, there are big stores of carbon that are contained in these native forests. We should be bringing them in that way into the climate change policy. And the forest industry says, well, no, we've got big opportunities to use these forests, the wood within them, for bioenergy markets. So today we'll be looking at these two arguments, and the aim is to be in a position where we can make our own judgment about what we think is a wise approach to forest policy, native forest policy for climate change. So I'm concentrating entirely on the native forest part of the industry, not the plantation part of the industry. The presentation has 4 parts. The first, I'll go through the arguments that the forest ecologists present and their key concepts. Then I'll do the same thing with the industry. Then we'll go through the quantification of these 2 arguments and conclude, or make the usual conclusions. So first now to the arguments that the forest ecologists put. And they have four key arguments, and they're all interrelated. The first is about resilience and biodiversity. And biodiversity is, and these issues are about the capacity of native forests to cope with change and to recover following disturbance. And it's entirely dependent on biodiversity. So maintaining and restoring biodiversity in native forests works like an insurance policy against expected climate change impacts, both the direct effects and the indirect effects, like changes in pest and fire realities. The second concept is about the carbon carrying capacity, and this is a crucial concept within the forest scientists, where they define the carbon carrying capacity as the amount of carbon that can be stored in a native forest or any natural ecosystem under prevailing environmental conditions and natural disturbance regimes, but excluding the disturbance from human activities. Now this is a landscape scale metric, and it's averaged over space and time. In reality, it's a dynamic equilibrium concept. Now the carbon carrying capacity is an important concept in investigating the effects of removing disturbance activities like by humans, like logging. The third concept is the landscape traps concept. Now we've heard more recently the work published by David Lindemeyer and his colleagues about landscape traps, where we have multiple feedbacks between human and natural disturbance regimes that can shift and keep entire landscapes trapped in highly compromised structural and functional stage. And so the implication, and linking it back to the previous slide, is that landscape traps are synonymous with reduced carbon carrying capacity. And the final concept is about longevity. So old forests have the largest stocks of carbon of any of the forest structures, and continue to be a small net sink in taking up CO2 from the atmosphere. So logging old carbon dense forests releases CO2 into the atmosphere. Now, putting these four key concepts together, the forest ecologists argue two things. The first is that we can avoid significant emissions by not logging native forests, and the second is that we can reap the carbon capture benefits as previously logged forests are allowed to return to their carbon carrying capacity, i.e. by not logging them again. Okay, so let's move now on to the industry arguments. Now, there are three main arguments, and again, they're interrelated. The first is that there are limits, in their view, there are limits to the carbon storage in forests, and if reached, then those native forests will not be able to remove CO2 from the atmosphere in a net sense. And so the forest industry focuses on flows, not stocks, and we'll see the importance of that through this seminar. The second point, and it's something we will spend some time concentrating on, is that substituting native forest wood for fossil fuels and carbon-intensive products, so those products that are made using fossil fuels, provides greater permanent reductions in atmospheric CO2 than using forests for biodiversity conservation, i.e. not logging them. And the third core argument from the industry is that the best outcomes for the atmosphere is to substitute fossil fuels for wood. Now, there are three important documents that I would like to draw your attention to that are presenting this case. The first on your left is it's a document produced in 2006 by the Cooperative Research Centre for Greenhouse Gas Accounting and the Wood and Wood Products Research and Development Corporation. It's called Forests, Wood and Australia's Carbon Balance. The middle document is a document released just this year, May this year, prepared by Martin Moroney for the Forest and Wood Products Australia. And the document on our right was released by the FAO Forestry Division in 2010, and it was prepared by Rod Miner, who works within the Environmental Research Authority within the Canadian pulp and paper industry. Okay, now within the forest industry's argument, we have had for many years now the presentation of this top graph, which comes from the CRC's document, so the document that was on the left-hand side. Now, in this graph, what we have is a mixture of a native forest regime and a plantation regime, and it's quite confusing. But we will focus on the native forest part. The blue sawtooth shape along the bottom is showing that when a forest is established, and in this case it can only be a plantation because we don't establish native forests, so when a plantation is established, then it takes up carbon, as you see with that blue line increasing. We do a couple of thinnings, so we have a drawdown, and we do the final clear fell, as you can see the big drawdown, and then we replant. So you see there that basically the carbon uptake and the emissions are basically tracking along. Now, the industry argues that yes, if we leave forests unlogged, we'll get that green dotted line. Now, in that case, the forest unlogged, I'm pretty sure means native forests. And some forest ecologists would argue that should be a little bit high, but nevertheless, that's a concept. The bit that I want us to concentrate and will concentrate on today is that steadily increasing black line. And what that is explained by the diagram below, which is taken from Dr. Moroney's document, the 2011 document. So if we start on the left-hand side with the native forest carbon stock, so that's the stocks of carbon in native forests. There's the argument that the industry puts that there's a limit to how much carbon can be stored in native forests. That's a saturation level. We have our emissions and we have our uptake. If we follow along into that wood products carbon stocks box. We obviously log native forests and use it for sawn timber and paper, etc. They have a certain product life, and at the end the carbon embedded in them is emitted. The crucial thing in this diagram is the fossil fuel substitution carbon stock. Now that represents two things. The first is the carbon that is saved from sawn timber displacing, say, steel that is made from fossil fuel. But more importantly, it also includes any use of native forests for bioenergy that substitutes directly for energy made from fossil fuels. So in other words, what is happening here is that under this framework, the industry is claiming that displacement of fossil fuel emissions from native forest wood acts as a permanent credit, which they are claiming to the industry. Okay. It is an emission from fossil fuels that is kept out of the emissions system, and it stays as a permanent deduction. It's an avoided emission, effectively. And so the reason for that increasing black line is because every time a fossil fuel emission is displaced by a native forest-based energy product, then it's claimed as a permanent emissions avoided. Okay, now I want to spend some time as to how this idea was generated, because clearly it's quite a tricky idea, as we'll spend some time on. There's a whole literature behind this framing, and it started in the 1970s and into the 1980s in the US with some research by Dyson and Marland. They're from, essentially it's a group of people with the International Energy Agency, the US Energy Department, and Oak Ridge University, so research-based universities. And by the mid-1970s, they were asking the very serious question of, if we really do need to buy time because of climate change, how do we buy time to be able to invest in the superior technologies for energising our economy? And so they looked at planting trees. They didn't look at native forests, they looked at the option of planting trees. And that work continued through the 70s and 80s. By 1990, some forest scientists got together in Harman et al. This also includes Jerry Franklin, who has worked with David Lindemeyer. And they asked the question, well, what would happen, how long does it take to recover the carbon from logging an old growth forest? So they moved the debate from a plantation debate into a what do we do with native forest debate. Their answer was, by the way, 250 years. But the really key point here was that, well, that's a key point, but the really key point here was that it started to shift the research into looking at native forests, not just plantations, in this climate change challenge. So by 1992, Marland had started looking at native forests, and the idea of using native forests for, or any forest, native forest or a plantation forest, for energy and substituting against fossil fuel as a permanent credit to forestry originated in that time, in 1992 with Marland's work. By 1996, Marland had joined up with a researcher in Austria, Bernhard Schlammerdinger, and had developed a model to start looking at various scenarios of native forests and plantations, and carbon stored in wood products and the fossil fuel displacement scenarios. Now in 1997 they were very busy, these people, almost put David Lindemeyer to shame actually. They produced numerous papers asking the questions of these two different land systems and what's best for climate, and their answer through it was, well, the answer all depends on many things. It depends on whether you're dealing with a native forest and its standing stock, whether you're dealing with a new plantation and establishing plantations on already cleared land. It depends on carbon densities, depends on growth rates, it depends on the effectiveness of fossil fuel substitution. Moroney, in his 2011 document, however, in framing how we look at native forests in the carbon story, made the following statement. The most effective way to limit greenhouse gas emissions through forest management, the most effective way, is to displace the burning of fossil fuels through the utilisation of wood products over alternative, more greenhouse gas intensive materials. Now, Moroney used, actually remarkably, Marland and Schlumerdinger's work and a number of other papers he referenced to. Virtually all of them, bar one, was dealing with plantations, not native forests. And the one that was dealing with native forests was actually spruce in Norway, which is arguable whether it was a native or is a native forest. And even then, it looks like leaving those forests unmanaged, i.e. unlogged, is a very attractive option. So from then on, from 1997 onwards, we're starting to see the work of Marland and Schlummerdinger ease off in their framing. And the two that I want to draw to your attention, the first one, Marland and Schlummerdinger, that was published in Mitigation Adaptation Strategies in Global Change. And they argued then that it's very difficult to attribute all the fossil fuel carbon offsets to forestry, and that indeed it was challenging to measure the amount of fossil fuel actually saved. And of course, I mean, this is quite obvious really. I mean, when we look at any industry, and let's just keep it in the fossil fuel industry, if fossil fuel production falls, is this because of displacement from native forests, or is it from displacement from true renewables, or is it because Saudi Arabia went on holiday, or is it because we had a global financial crisis, or was there energy efficiency coming in here? It's virtually impossible to tag what happens in one industry directly onto another industry. The second paper that I want to draw your attention to from the 1997 grouping is by Marland, Schlummerdinger and Leiby, and the Critical Reviews in Environmental Science and Technology, where they say it's likely that current emission reductions are more valued than future reductions, which we know because the climate change challenge is with us for most immediately in over the next 20, 30, 40 years. And they're saying that same point, is that the challenge is much more immediate than in the future. So that favours avoiding emissions today and protecting carbon storage in forests. And the final paper in 1999 from Marland and Schlummerdinger, which was published in Tellus, is that net emissions can continue for a very long time, perhaps centuries, even with full credit for fossil fuel saving and wood product storage. So what we have here is an industry frame based on some theoretical constructions done in the early 1990s, where the authors of those theoretical constructions have produced quantified work that isn't quite in harmony with how it's being used by the industry today. So, I think we can say at this stage we've got a state of confusion. So we... Can we take questions? No, at the end. Yes, at the end. I'm really confused that you say that. Yes, I'm sorry, but we're on a strict... Yes, I'm sorry, but we're on a strict time. The native forest industry to the plantation industry. Right, thank you. As you were to, excuse the interruption, I wouldn't help myself. Apology accepted, of course. Now, what we have, apart from the interruption, is some confusion here between what the forest ecologists are saying and what the industry is saying. And the confusion is over core concepts, carbon carrying capacity, saturation levels, do old growth forests reach saturation levels or not, and so on. But in my assessment, The confusion lies more within the industry side. It's very difficult in reading a number of their papers whether they're talking about plantations and native forests. And as I say, I'm not talking in this seminar about plantations. I would very much like to give another one next year about the issues of plantations, which I think are actually more complicated. But it is very difficult from the industry arguments and the industry publications to actually understand what resource they're talking about, plantations or native forests, and of course that's critical. The other thing I think that's a serious problem is that the concept of time is being overlooked. And here the concept of time is not in 100 or 200 years. The really critical time period is between now and around 2040, 2050. The third concern I have is that the claims of fossil fuel substitution, when it's effectively impossible to tag fossil fuel substitution by any industry, whether it's a native forest bioenergy industry, or whether it's energy efficiency, or whether it's solar. And I should also point out the IPCC does not allow such tagging or crediting in any of their accounting. And finally, in this very point, from a policy perspective, not an accounting perspective, but from a policy perspective, if we were to look at fossil fuel substitution, the two areas that we would want to put our research dollars into and our facilitation energy into would be in the areas of true renewables, solar, etc., and also, of course, energy efficiency. Okay, we'll move into the third section, which is bringing these two sides together. And I want to start through a quantified analysis. And I want to start this off by looking at what the native forest industry is today. Okay, in these four graphs, if you concentrate far less on the vertical axis because they're slightly different units in their measurement, and concentrate more on the trends within them. We'll start from the top left-hand one, which is a snapshot, or it's a time series data of logging volumes from both native forests and plantations. So we see the middle line being the plantation log cut, and we see, and if we actually extended it back into the 1980s, we actually see that darker green line increasing quite dramatically in the 1980s. And we also see in that graph the downward trend in the native forest log cut. The really most crucial piece of data here is the actual top line, which is the projected plantation resource supply from what was then the Bureau of Resource Sciences. And there is no doubt we can have arguments about the size of those projections. I think they're perhaps just a little bit too high, but even discounting them, that increasing plantation resource will drive the structural change that's already well underway in Australia, and it will drive it over the next 5 or so years. If we move across to that hardwood chip export graph, this is the main reason why we're seeing such a dramatic change and crisis within the forestry industry, because it is its biggest volume production is happening in the chip export market, which is what this graph's about. We see there this very strong growth in the hardwood plantation chip exports. It's now overtaken the native forest chip exports, and we see this very strong downward trend in the native forest chip export, and that will continue. And we know it will continue because this is data up till June 2010, and we know what's happened, particularly in Tasmania, since then. Now, the bottom two concern the sawn timber and wood panels sector. The one on the far left is and this is data for ending June 2009. It's actually 2 years out of date, and largely because, only because ABARES is having trouble reporting on hardwood sawn timber production. In more recent years, again, there is a significant structural change happening, but already the native forest part of this sector of the industry, which is sawn timber and wood panels, is producing somewhere between 10 to 15%, that's today, somewhere between 10 to 15% of that product. The main reason for it being so low is the native forest sector was not able to get into the high growth wood panels markets like medium density fibreboard, etc. And the second main reason is because the sawn timber industry was getting such strong competition from the plantation sector, which is what you can see on that right-hand bottom graph. We will see the plantation production continue to increase, but certainly not at the rates of the 80s and 90s. I've also included in there that bottom line, which is the green line, which is hardwood sawn timber imports. There are many people who are worried about hardwood sawn timber imports, particularly from rainforests coming into Australia as a result of reductions in native forest sawn timber production, whether that's because of environmentalists or whether it's because of the softwood plantations, it doesn't matter. The worry is that there will be an increasing imports of rainforest timbers. Clearly this has not happened in this entire period of downward trend, and I would argue that people who are concerned about rainforest imports haven't got much to worry about. Okay, let's move into the quantified analysis, and essentially what I'm saying here is that the future for native forests is not in the traditional markets, we know that, and if native forest logging is to continue at the levels that it's been used to over the past decade and two, then new markets are required, and hence the industry's interest in the bioenergy market. Okay, so what we've done is prepared a scenario where we've assumed, well, okay, we'll maintain the native forest log cut for saw logging. We'll run all of that through into the sawn timber product ranges. We'll ignore any plantation competition, and we'll put all of the chip logs and all of the sawmill residues into bioenergy. What are the climate change implications of that scenario? Now, rather than using a black box, a National Carbon Accounting System type black box, what I've gone through and done is specified the data sets and the assumptions for the three key groups of information that we need to do the calculations, and I'll run through those quickly. The first, in terms of the native forest management regime, I've assumed a 100-year rotation with a mean annual increment of 2 cubic metres per hectare per annum. That comes from the Resource Assessment Commission, which is an average over Australia's public native forest use for wood production. I've assumed that 35% of the log cut is from saw logs, which is quite a standard ratio, and 2% goes into poles, posts and sleepers, again a standard figure, and that all chip logs and sawmill residues go into bioenergy. In terms of the second group of information that we need in the forest biomass and regrowth, I've used Grierson et al. A 1992 publication for the growth curve, the regrowth curve. That's had an amendment to it to shift it from a polynomial, which at 100 years goes down, to an exponential, which is that steadily rising. I've assumed and because that work looks at above ground living biomass, I've assumed a root to shoot or a below ground to above ground living biomass ratio of 0.25 to 1. Again, this is standard within our approach. And that gives a ratio of merchantable wood in a forest of 37% of the above and below ground living biomass in a native forest is merchantable wood at year 100. In all of this, I've also excluded soil carbon and dead biomass. In the wood product's life, the third part of the information base we need to draw up, I've used the products and product pools from Jaakko Puri, that was work published in 1999 for the National Carbon Accounting System. And in that, with 85% of the sawn timber going into framing boards, flooring and furniture, and giving it a full life of 90 years. Okay. So in terms of running this through, we get the first outcome displayed in this graph. So it's looking at sawn timber and bioenergy over a 100-year rotation. At year 0, when the forest is ready for logging, we have a carbon stock of slightly above 300 tonnes per hectare. We log that forest and we put the merchantable wood into two products, largely two products, sawn timber with a little bit into poles and posts, etc., and the rest goes into biomass energy. In year 1, I've assumed that none of that is combusted. Okay, so those two products, a bioenergy product and let's just call it the sawn timber because the other bits are quite small, is that red bar. By year 10, the bioenergy is combusted, so that now is an emission, and that's the reason for that dramatic contraction in that red bar. It's the bioenergy being combusted. Okay, the forest regrows, as we can see with the green. By year 90, we've got basically the forest back to close to its carbon carrying capacity for a 100-year rotation. We're still the sawn timber largely at the end of its life. By the year 100, the sawn timber in framing and furniture, etc., is assumed to be out of wood storage or carbon storage and has become an emission, and the forest is basically returned back to its original position in 100 years' time. Now, the crucial point about this is that yes, if we start at year 0 and go to year 100, that's carbon neutral. But if we're looking at climate change and our challenge being largely by 2050, if you run your eye to 50 or 40, and you see that in that entire period, it's certainly not carbon neutral. So in the most crucial period for our policy making and coming to grips and getting on top of the climate change policy, logging a hectare of forest today is only making our job more difficult. Okay, now if we move into the atmosphere, because that's really what the policy goal is, it's reducing the stocks of atmospheric CO2. If we move to the atmosphere and let's see what's going on. So in other words, we're really just flipping this around. If we concentrate on the left-hand side, we've got the atmospheric stock of carbon from bioenergy and wood products. So again, you can see at year 1, there's no build-up of CO2 stocks in the atmosphere from wood products, largely because we haven't started combusting the bioenergy. But from year 10 onwards, the atmosphere is worse off as a result of logging a hectare of native forest for bioenergy and sawn timber. Okay. The graph below is looking at the atmospheric stock of carbon from native forest logging and regrowing, and you can see that the stocks are building up in the first part of this 100-year analysis, and then there's a drawdown. If we combine those two things, we move across to the graph on the right-hand side, and again, it's what we're saying here, it's flipping it around. The net effect on the atmosphere of logging a hectare of native forests for sawn timber or bioenergy is negative for the entire duration of that 100-year operation, except in year 100. Okay, so one of the things that I learned from scientists is this concept of scaling up, and so we've been working here with a hectare of native forests. How might we look at this and scale it up? And the one way of scaling it up is to ask the question, well, if we used all of our 2009 native forest log cut, or slightly over 6 million cubic metres, we have to convert that into tonnes for the next exercise. If we used all of our native forest log cut for bioenergy and substituted it all for fossil fuel emissions from the production of electricity in Australia, so coal-based electricity I should say, how much could we reduce our coal-based electricity by. The calculation's actually quite simple, and I've made it even more simple. We produce electricity in Australia by brown and black coal. We've got our tonnages of brown and black coal extracted for electricity production, which is the left-hand bar. We have energy content factors that are produced by the Department of Climate Change and Energy Efficiency. What we really should do is convert the volume of coal into electricity by deducting off the energy required for transport and processing. I've chosen not to do that because it makes the calculation much more complicated, and also because it actually costs more energy to convert a tonne of wood into electricity than it does to convert a tonne of coal into electricity. In other words, these results are biased towards the native forest scenario. Now, to look at energy, the energy capacity, we might call it then, we have in Australia 2.2 million gigajoules of energy produced from coal. If we looked at the capacity for energy production using all of our native forest log cut, it comes to 62 million gigajoules. Now, if we divide 62 by 2206, we come to 2.8%. In other words, if we logged all of our native forests in Australia at the same level we did in 2009 and moved it all into energy production and substituted it against coal-based electricity, we could reduce our coal-based electricity production by 2.8%. Now, we know that no new emerging industry likes to have a market share of 2.8%. I mean, you know, it's not atypical to have an aspiration of around 10% market share by around, you know, within a decade's time. So if we were to see the native forest industry become, you know, aspire to a 10% market share, this would require a tripling in native forest logging. Okay, and a tripling in native forest logging to be able to maintain that as a sustainable supply would require, or the implication of that would be a permanent reduction in the carbon stocks in native forests. So there's some pretty big issues here. And the way I've presented it too is that it's virtually impossible to imagine, it is not possible to get an outcome where we log a hectare of native forest or 10,000 hectares or whatever hectares of native forest today and not have them as major emitting problems over the next 30 to 40 years, that crucial time for getting on top of the climate change challenge. Okay, so some conclusions. So, logging in native forest stand today cannot be carbon neutral over the critical period for climate change policy, i.e. the next 30 to 40 years. Understanding stock changes over longer periods, so through to 2050, is much more important than understanding annual flow rates. The global atmospheric CO2 stock in 2050 will determine climate impacts, not annual emissions rates. With native forest sawn timber a declining remnant and chip exports being rapidly displaced by Australia's hardwood plantations, opening native forests to the bioenergy market will be all pain for no gain. And the other part of the pain that I haven't mentioned today is the ongoing social problems of conflict in Australia's forest regions. Now there's a big wake up for me, there's a reality of serious data availability and quality problems within our knowledge of native forests and their carbon stocks and their uptake of carbon. And these problems are so serious that I effectively rule out native forests from inclusion in the carbon market at this point in time. And it has been a big opener for me. And when I mentioned this to one person, the comment was, well, it's these sorts of environmental data sets on which our economy is founded. So that was quite a humbling comment. So the final conclusion is that in doing climate change policy, we should separate native forests from plantations because they are fundamentally different ecosystems with different carbon stories and also economic prospects. Thank you.
Thanks, Judith. I think already we've learnt today that, one, it's a very complex issue, and also values around native forests are very strongly held. So I'll open the floor to questions.
If I might. In your model, you suggest that all current biomass material and wood chip material will be used for bioenergy production. Now that's never going to happen. So if we have something that will never happen as a fundamental basis to your argument.
Could you identify yourself, just so we know?
Peter Rutherford.
Yeah. Well, first of all, I didn't say all biomass to energy. That's the last one in the scaling up in terms of a what if.
You included all sawn timber.
The last one included all biomass for energy in the scaling up exercise. In the main part, what I put in there was if native forest logging stays with a sawmill component, okay, so that 35% of the log cut from native forests remains as sawn timber, and the rest goes into chips for bioenergy, with all the sawmill residues going into bioenergy, what is the implication?
That's what I'm saying. It's something that will never happen. So I thought you were an economist, so you'd have an understanding about some of the basics of the industry that you've shit canned since the 80s when I listened to you down in Melbourne. You might remember that day, or I remember it very well.
Well, that's your comment on it will never happen. I think there'll be many people who hope you're right.
No, I don't gamble. I don't believe you gamble, but I'll take a bet on it.
Other questions?
In your accounting framework of your scenario, so I understand that you explained at the beginning all these issues that we don't know exactly, but so did I miss that you were not avoiding fossil, so in your accounting that you're not using the biofuel to do some sort of avoidance of fossil fuel emissions and therefore atmosphere?
Yes, that's right. I should have specified that I was ruling out the substitution of the native forest bioenergy from fossil fuel, and the reasons why I was ruling it out was one, it's impossible to track it anyway because of the dynamics of what goes on in an industry and here the whole energy market. Two, the IPCC doesn't allow it, and three, if we were to look at this from a policy perspective, we would put our R&D effort and our facilitation effort into superior ways of energising the Australian economy from a climate change perspective. And those superior ways are energy efficiency and truly renewables.
This is all right, it's fantastic, but from an accounting point of view, what the atmosphere sees or doesn't see, which is the climate change impact, you cannot skip away from within your framework to have some sort of a avoidance component. You can give it a big uncertainty because it can be very low. Actually, some of these processes of avoidance from biomass actually are very low efficiency from that, maybe just 20% or 30% avoidance. But from a point of view of framework, you don't want to leave it completely out.
Yeah.
That happens to easy criticism. Right?
Yeah. Well, it's a boundary issue, and the best way of handling the boundary issue here is by actually expanding out the whole analysis so that you're looking at the entire energy industry. That's the best way of building the boundary here.
I wasn't paying attention. I didn't catch the gentleman's name.
Yes, sorry. Could you introduce yourself?
Thanks for that.
Any other
So
questions?
we apply the rules to everyone?
Yes, we will, sir. We will, sir. Could you introduce yourself before you can?
Sean Burke is my name. just to extrapolate on Peter's scenario there, you're saying that if we maintain the 35% in timber production, the other 65% in your situation you had looked at that going into bioenergy, to then say reduce that 65% say to 10% with 55% going into wood chips for paper production, for example, and the cycle of that paper in terms of then releasing the carbon, what would be the net impact of that in terms of your scenario versus, say, Peter's scenario where it's 55%, 10% in terms of the carbon cycle and the impact on atmospheric carbon? How would that differ between your scenario and, say, for example, another
Yeah.
example?
Yeah.
That would be more along my Peter's thing.
Yeah, well, it gets back to product life. Okay, so in this scenario, the bioenergy is combusted quite early. In the paper, then it gets into product life. So how long does paper live? And then what happens after the life of that paper? Does that go into, into a fuel regime and it's burnt, or does it decompose and etc.? So the issue here is if you were to put it into paper versus bioenergy, you would be lengthening your wood storage. Okay, but in the total scheme of things, it doesn't really make terribly much difference. Yes.
More than 30, 40 years.
Yes. So the crucial issue here is that from a policy perspective, well, let's put this into perspective. In Australia, we use slightly over 500,000 tonnes of native forest wood for paper production. Okay, the only location is in Maryvale in Victoria. Okay, 500,000 tonnes is very, very small. We've got a hardwood plantation estate, which the BRS, or now ABARES, is projecting to supply by 2010, mind you. The industry can't gear up for it, but 14 million tonnes, 500,000 tonnes, 14 million tonnes of hardwood. Now, I think that 14 million is too high. Let's reduce it to 10 million. Okay, those huge differences in resource, 500,000 native forest wood for paper production in Australia, 10 to 14 million coming from plantations, hardwood plantations. The research effort, the processing investment capacity will all be on the plantation sector. To imagine that native forest is going to become, the paper producer of Australia is not possible to imagine.
Judith, where is this analysis going to appear?
Well, as I mentioned, we've got a little team and we're starting to write a paper up and we will find a good journal.
So we're talking in the next 6 to 12 months, this will be publicly available?
Yes.
Any other questions?
Will the paper be peer reviewed?
All our publications that go into journals are peer reviewed.
Okay, well, I'd ask you to join me in thanking Judith for a very interesting talk.
Thank you.